Now we're going to look at some examples where limits fail to exist. Remember on the previous page, I ended up by saying it is really important that we look at the fact that that y value is getting closer and closer to a certain number from both sides of my point in question. When I'm looking at the limit as x approaches 0, I'm interested in both the positive and the negative side. So we want to come up with some situations here where the limits don't exist. So we're going to start off by sketching the graph x minus 1 over the absolute value of x minus 1. And you can plug this into your calculator if you need to see what this looks like. But basically what we end up with is that we are going to have two straight lines that look like this. Whenever x is greater than 1, it's going to be positive. Whenever x is less than 1, it's going to be negative. And you could plug that into your calculator or work some out by hand to see that this is always going to be the case. So if I look at this table here, if I plug in a 0.9, I'm going to be negative 1. If I plug in 0.99, it's negative 1. 0.999 is negative 1. When I get to 0, though, I'm undefined because I'm going to have a 0, or I plug in a 1, I'm going to have a 0 in the denominator, so that's undefined. And then anything larger than 1 is going to be positive. Now, this is a little bit of an issue here. When approaching 1 from the left, the y values go to negative 1. And when approaching from the right, the y values go to 1. So this is the idea that we are going from the right to that point of interest. And if I'm going here, it is from the left. I know you're actually moving to the right, but it's coming from the left. And you can see right here that the y values don't approach the same number. So in this case, the limit does not exist. That's a DNE. The limit does not exist. And when I say the y values don't approach the same number, just flipping back to the previous page, you can see right here in this example, we were getting closer and closer to this implied 2. If I went back to the one up here, closer and closer to an implied 3. Over here, you're not getting closer to some number. So we run into a little bit of an issue there. You also know that the graph isn't connected. It's not continuous at that point. So that does make it to be a little bit more of a challenge as we're doing limits. The second one, sketching the graph of y equals 1 over x minus 1 squared on the axes provided. Well, from what you can observe here, you're going to have a vertical asymptote at x equals 1 because that x minus 1 in the denominator doesn't cancel. And normally that would be a rational function that has a piece that sort of looks like this. But since that x minus 1 quantity is squared, that means we're going to be positive. So my general shape is going to look like this. We've got a horizontal asymptote at y equals 0, a vertical asymptote at x equals 1. So as I approach 1 from the left, so as I'm going in from the left, you can see that the y values go up to infinity. That's the infinity sign. Higher and higher. And it goes without bound. When approaching 1 from the right, the numbers also go up to infinity along that vertical asymptote. So if I were to plug in 1.1, then 1.01, 1.001, 1.000000001. Lots of zeros in there. I'm getting closer and closer to that vertical asymptote, which means my output is going to be some huge number. It's unbounded. It goes to infinity. Therefore, the limit does not exist. Infinity is a concept, not a number. And in order to be a limit, you do need to come to some specific number. You've got to converge on a specific number. So to summarize, the limit is going to fail to exist if the y values differ on the right and left side, or if we have unbounded behavior. Those two things, the limits are going to fail to exist. Now let's just do a couple of examples at the bottom here that might be a little different. But let's do the limit as x approaches 1 of x squared plus 2. Well, if I were to look at this graph, it's a parabola that goes up. And is there any hole in here? And the answer is no, there's no hole. But what I want to know is what happens as I get really, really close to 1? What y value do I get really, really close to here? And the answer is I get really, really close to 3. If I were to plug in a 0.9, 0.99, 0.999, so if I were to do, say, an XY chart here of 0.9, 0.99, 0.999, and 1, 1.001, 1.01, something like that, I would see that at 1 I have 3, and then this would be something like 2.9. I don't know exactly what they are, but there's going to be some 2.99s going on there. And then on the other side, you're going to have something like 3.01s. I don't have the exact numbers, but you can see this idea that it appears to approach 3. The reason why I show you this is as you approach on both sides, it's okay that your answer is actually the limit. That does happen if there's no holes, no asymptotes. But it's the concept that you're looking at. What are you getting closer and closer to as you come from the left and from the right, and are you approaching the same number? The other example I want to show you is what happens if you have a piecewise function. What happens if you were to have f of x equals x squared plus 2 when x does not equal 2, or excuse me, does not equal 1, and then it's going to be equal to 1 when x equals 1. So you get some piecewise function. Well, the situation you have now is that you're going to have a hole there at the point 1, 3, and then a filled in circle right there. And I want to know what is the limit as x approaches 1 of this going to be. And this is one of the most missed ideas of limits. The answer here is that it's going to be 3. It is not the filled in circle, because the whole idea of a limit is what is happening as you get really, really close to the point. So I'm looking at what's happening here, 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 really, really close to that point. And as you can see, I'm getting closer and closer to 3. Just because it's defined as a single point off to the side doesn't give us a limit at that point. The limit is what is happening as I get really, really close to 1. And as I get really, really close to 1, the answer is 3. Yes, at x equals 1, the answer is 3. But the idea of a limit is what's happening as you get really, really close to 1. And you can see that you're getting closer and closer to 3.